Well, thank you all for joining, and thank you, Karen. That was a great introduction. We'll see if I can live up to it. Well, the title that you see on the screen is not quite the same as I chose for the title for the webinar. They relate, and what I want to point out is that metal detectors are lightweight, handheld, near-surface, in-phase electrical conductivity meters. They are a geophysical instrument. So there is a relationship here. Let me point out that I've run the gamut of talking to folks about metal detectors, both positively and negatively over the last 30-odd years. And what people don't largely know, archaeologists, is that we as a profession have used metal detectors since the 1950s. Quite a few of the people using them in the 1950s, and including a number of very prominent archaeologists, didn't talk about it because it was a bad thing, or they thought they would be castigated by their peers, and some were, as a matter of fact. But it's not a new tool. It's just there. And I've actually run into a couple of cases that just background is I was talking to somebody at SAA one time, and the individual said, well, how can you possibly use metal detectors? They're the devil's tool. Well, I respond, and obviously meaning in terms of people who loot sites, and they do with those tools. My response was, well, do you use a shovel? And he said, yes. And I said, well, looters use shovels. Does that mean we shouldn't use that tool? I think the point was made. I've also heard comments like, well, all you can find is metal. Well, duh. Yes, that's what they're designed for. But that's not any different than going out and finding a lithic scatter and only finding rocks that might and lithic debutage that might tell you something about what's happening on that site, and there may be buried components you have to do in a traditional manner. So this is just a tool, and I want to emphasize that all the way through this. I'll give you a little bit of history. Metal detectors are not new. They were not a result of World War II mine detecting technology. They were developed in 1881. You may be surprised to learn that the individual who invented the metal detector was, in fact, Alexander Graham Bell. The guy that made that telephone possible. He, in the process of working with telephones, he realized he had a tool that he didn't quite understand, and it was induction, electrical induction. It was an important part of the telephone. Then he realized you could do something else with it. And so he developed this thing, and his idea was to use it for medical purposes, to run over wounded people to find metal fragments, particularly bullets, that might be embedded in bodies. So he thought at first of as a medical instrument. He applied that when President Garfield was shot by an assassin in 1880 in the 1880s. And then in that process, he was brought in to use his induction machine to find the bullet in Garfield's body. And as Virgil Noble knows, if he happens to be listening, that it didn't work very well. But there are a couple reasons for it. First of all, the surgeons who had been working on Garfield had been using their fingers to probe around in there, and may have caused a wee bit of infection that eventually killed him. But Bell got all sorts of little clicks when he ran his induction machine over Garfield's body, placing one antenna underneath the bed that he was laying on and one passing over the body. Little did Bell know that Garfield had a new invention of his that he had recently purchased to sleep on, and that was an inner spring mattress. So he got all of the metal and could not find the bullet. It's tried a couple of times. It just didn't work out, unfortunately. He almost gave up on it at that point. By the way, there's Garfield's spine with a bullet hole in it. That's on display at the National Museum of Medicine and Health in D.C. Metal detectors began a slow development through the 19th century. Various kinds of were actually developed based on Bell's principles, and they were used largely for finding ore bodies in the earth. As you see it there, they also were for salvage, for sunken vessels and treasure, of course. So they were around and have been around for a long time. Of course, the modern underwater metal detector, which is a pulse induction system, as shown there as well, just for juxtaposition. So there's a long history of these detectors being around. The person in 1927 who really set off the metal detector as a modern invention, if you will, was Gerhard Fischer of Fischer Labs, now in California as part of Technics. And he invented the serious first metal detector. There had been attempts to use it in World War I as a counter mine device, and it didn't. It was not particularly effective because the technology hadn't come along. But it was Fischer who took it to the next step and is sort of considered the father of modern metal detectors. And metal detecting really came into its own during the Second World War. There's some British anti-mine detectors and an American World War II mine detecting unit, and then a modern one. There are many, many different kinds of models and brands out there today that are very effective at finding in mines, and particularly been used extensively within Iraq and Afghanistan today, and are the basis of new developments in the hobbyist and professional use of metal detectors in archaeology. I had to throw this one in. I apologize, but this is the early two-box system, of which we still use one today, developed by Fischer. It's the only one I could find a picture of from an old ad from some treasure hunting magazine back in the 50s. So again, you can see how far they have come in principle, and we'll get to the uses and advantages here and also give you a few case examples. Again, as Karen said, feel free to break in if you have a specific question or subject matter here. But metal detectors are going to detect the presence of, in a point operative word, near surface buried metal objects. And that's a relative term. We'll come back to that, talking about certain other detectors later. They're very easy to use, and there's a very short learning curve. Basically, a can learn to use a metal detector, how to turn it on, how to listen to tones, in probably an hour or two. Become proficient in their use is another matter. That takes probably 100 hours of operation to get competent, really competent in that. But you can learn to use them fairly quickly. It depends on what you have to do with them. The measurements are rapidly acquired. They are continuous measurements. In other words, you're constantly getting feedback from whether or not you hear a tone or see something on a screen. They have excellent definition. You can pinpoint very shallow targets very precisely. Largely, the most VLF, very low frequency metal detectors, will have a range of around 30 centimeters. Some will go deeper, significantly deeper, but those tend to be the most expensive and hardest to learn to operate. The average ones are usually around 30 centimeters, and they really can pinpoint and identify targets. Particularly modern current models of metal detectors are very good at telling you at least what type of metal you're likely to encounter. So the basic components of a detector are very, very simple. You've got a control box seen in the kind of center of this image. This happens to be and I'm going to mention a bunch of different brands today. I'm not endorsing any of them. I don't get paid by anybody to do this. But these are brands that I have used or tested for various metal detecting companies, so I use them as examples. But there are many brands out there, and they're very good. But the control box is the electronics that send and receive signals. You have the wand or shaft that supports the operator's arm, and also the antenna, and then the coil or antenna, which has a receive unit in it. You have an antenna cable that's either internal to the wand or, in this case, wound around the outside of that particular shaft and connects up to the control box. And our general rule of thumb on cost is that it's about $100 per inch. You can go buy at one of the sporting goods stores a $100 to $150, $200 machine. If all you're looking for is the first inch or so of soil, that's fine. But if you want anything more than that, if you want to reach deeper and get better definition on your targets, you're going to have to pay more money for them. They run up to about $2,000 to $3,000 for a high-end VLF machine that works on multiple frequencies, very low frequency machine. Or you can go to the Pulse Induction, and they'll run anywhere from $3,000 to $5,000. Pulse Induction does not discriminate currently, but will go as deep as 3 feet or a meter, and find something as small as a sewing pin or needle. But the VLFs are the ones we use, and they come in single frequency or multiple frequencies, sometimes 3, sometimes up to 23. The multiple frequencies are slightly better in that they give you a lot, many more continuous readings and cover the fuller range of metal buried in the surface. Here's just an image of a few different types of metal detectors, including the yellow one on the right, on the left, which is a Schonstatt, which people still use for a lot of basic stuff in finding very deeply buried cables and pipes and that sort of thing that are metal. These are just a variety of brands and types, as well as a couple of small ones on the right, which are handheld probes that with your larger coils you can't find stuff in the ground once you start digging quite as easily, and the handheld probes only work for about an inch around their end, around the terminal end of the receiver. So they, but you can find things very nicely and with minimizing this earth disturbance that you're dealing with. A lot of different kinds of displays, and these have changed quite a little bit in the last 2 or 3 years. From just a tonal, all of them have an audio output of some sort that changes tone with the type of metal. They're not consistent among brands, but in a given brand, they are, generally speaking. They also have digital readouts of various types. The one that in the lower right there is a MindLab QuattroPro. It gives you a readout and gives you as just one example of many different types that are available. New ones out have color screens on them, and I'll show you an example of that in a little bit. The largest advance in metal detecting in the last 10 years has been one in coil technology, the antennas, and you can see all sorts of different ones here. In all sorts of different sizes, open loops to closed loops, open elliptical versus circular, and so on. It really depends on the job. Just like a ground penetrating radar, you use different antennas. Same thing with a metal detector. For any near surface stuff, anywhere an 8 to 11 inch coil is usually good, and whether it's elliptical or circular doesn't really matter. The elliptical ones allow a little bit better manipulation in rocky or brushy terrain because you can get into places you can't with a large coil. Just something to keep in mind when you're looking at it. Now, here's an ideal place to go metal detecting. Broad open area, scenic. This has to be at Little Bighorn. That's Charlie Hacker from Santa Fe, Larry Ludwig from Fort Bowie, Park Service, and on the right's Chris Adams from the U.S. Forest Service in Truth or Consequences, New Mexico. Probably 3 of the best metal detectors I've ever run into. We can also work in a variety of environments. This is at Sitka, Alaska. You can work with metal detectors when it's wet, which we did, helping Bill Hunt look for a Tlingit fort that was shelled by or bombarded by the Russians in 1805. And we found this stuff, too. We had to wrap our detector coil or control boxes in plastic to protect them. Now, newer detectors have full waterproof coil box or control boxes, and some do, some don't. You have to, if that's what you need, a wet environment work. Some are totally submersible. Some of the VLF machines are totally submersible now. Others, you can't get them wet. By the way, you don't want to use them in environments where you've got a lot of lightning because they will act as a lightning rod. The methods. How do you go out and do an inventory using a metal detector? Well, it's exactly the same as you would in any other kind of situation. This is a tool. How you use it to sample a site, and what you're doing is like you do in any survey, is walking transects or whatever it might be. Your imagination will make it work. What is your goal? The closer you space a metal detector in walking a transect, the better recovery you're going to get for information, as would be in a visual inventory. You can do them, radial. You can do them, and that's been very effective in certain kinds of sites to determine boundaries. You can do it linear. You can do it. When the VLF machines were single frequency, people largely advocated doing a perpendicular, doing one set of transects one way, then using another VLF machine on a different frequency in 90 degrees to that. That's a great technique. Today with the multi-frequency machines, you don't need to do that. But again, the method you use is you're going to get information. The wider your transects, the less information you'll receive. But if you're looking for boundaries of sites, or even just find a site, a 10-meter wide transect might work. Something else, you might want to go, shoulder to shoulder. It's just like any other inventory technique. How much information do you need, and how are you going to apply it? Which is the best? So there's no right answer to that. It's the project-specific situation and the data that you need to acquire. Here's just an example of some volunteers who are learning to use metal detectors in the Southwest. This is Charles Hacker from, again, Santa Fe, working with some Native Americans and other folks, and showing them how to use detectors. And again, fairly easy to learn and get a handle on. Again, proficiency comes with experience. The critical element of using the metal detector, think of this as sampling. The better you sample a universe, the more information you're going to have that will be useful. So actually using a detector in a sweep, no matter what kind of transect you might be using, this zigzag pattern, which says incorrect there on the left, will work, but you're going to miss a lot of data. So it's a pretty gross sampling thing. If you're in a hurry, that might be okay to use, but generally not. If you use the correct one, which is also easier on your shoulder and your elbows and your hips, in walking a transect, is using nice little narrow U-shaped pattern overlapping sweeps. One, you get better information. Two, ergonomically, it's much better for you. And setting that detector so that when you use it, the length of the wand is so that you can stand upright and really be a bipedal kind of person is really important. So hunching over is not the best thing for you. You get pretty tired pretty quick. So that is more critical than how you do your transects. And so it's using that detector properly. And that U-shape overlapping sweep is the best technique that's out there at the present time. Now, here's an example of a new, just issued in the last 18 months, Mind Lab. And I'm not a proponent or advocating Mind Labs because there are lots of other good detectors out there, but I just wanted to show you an example of one of the newer machines. And it's got a lot of bells and whistles on it. This also costs $2,500. It's color screen. It has a GPS built into it, hiking grade. It has a number of capabilities. It shows you the direction you're walking. You see the grid system there on the left image of the actual control box console, and lots of buttons to push. And that grid can be as small as 10 meters or as large as a couple of 100 meters, depending on what you want to do. As you displayed on that, and I don't know how clear it will be on your screens, but are a series of yellow and brown digital signals. It's reflecting a metal target, and it is constantly sampling that and giving you the hardest return. The location on the screen, there are also digital readouts and audio signals that you can pick up that will tell you roughly the type of metal it is. In that case, we're looking at aluminum or possibly brass. So, and again, it has some other information on it. You can switch this to a mode to record your transects or your manner of walking area, and you can record with this one your find objects. It's very simple, GPS and GIS unit. The right screen, or right element on the screen you see is shows the transects and the finds along the transect. It shows my, now let me get the pointer up here, and you can see it shows my starting point back and forth. I zigzag or loop back and forth and ended up here at the checkered flag. I won the race. These 4 items there are targets that I recorded as I found them, and this as a proprietary software called Exchange 2 from MineLab. And let me show you the next image here if it'll come up properly. This is the screen that you do in editing on the computer, and in this particular case, it's a brass Gallagher Civil War cartridge case. It gives me my latitude and longitude. That's the only option you have, unfortunately. I can put a description in. I was able to tag an image to it. I can put some more information. One of the important things for me is down here under target, it records its conductivity ranges. And each manufacturer decides what their own conductivity range is in. So, but it's ferrous content 14 and high conductivity range is 25, which would indicate brass, and it gives me a depth of the find at 15 centimeters, which it was not found at 15 centimeters. It was found at about 5. So depth is, in metal detecting readouts, are only approximations. They're based on certain principles that don't always apply what we do. It tells me the mode I'm in, which is I created a customized minimum discrimination mode. And so I'm not discriminating out any metals. Sometimes you can set them to discriminate out iron or aluminum, but you also lose other things when you do that, because we're dealing with, in metal detectors, the electrical conductivity properties of the metal itself. And so aluminum and brass conduct similarly, which is why they show up in wiring in homes. So that's just the case. This gives a little bit more detail here in this image that's captured. It links to Google Earth. This program links to Google Earth. A lot of good points to this. The negative is that in this particular version of the software, I cannot link it. I cannot upload this to Excel or a shapefile. I have to hand enter it and work with it that way. So I can't transfer this at this point because it's proprietary software. I think the next version they will be changing that, because for law enforcement work or other things where they need to have it into a database. And then particularly in our field in archaeology, you can't do that. And I think they will change that and make it more desirable for archaeologists. Now let me give you a few case examples, and in the process I will be talking more about capabilities and equipment types and what's being done. This is a site in Germany that was found by metal detecting, and it's kind of an important one. It is where Varus's legions were destroyed by Hermann in 9 AD. This is one of the oldest sites I know of, actually found by a metal detector. He was an amateur working within the constraints of the requirements of the German government, who had to report all of his finds. And when the archaeologists looked at his finds, he had a working hypothesis that the Kalkrisa site where Varus's Legion was destroyed was in this area, and he did find evidence of it. And this is one of the things he found with a metal detector. You know, he was pretty excited, and it's an important find. But all of this came together with him. He's a major in the British Army. He's retired. In fact, I believe he's deceased now. But he did a great job in working with the professional archaeologists. And when the professionals came in, they continued to use him to help them identify set areas of the site that were then tested by traditional means. And as a result, the professionals were able to find the wall where that had been built up by Hermann and his German troops, and to catch Varus's legions in a real narrow, what today is a nice wide lush valley, but then was a narrow strip of land through a swamp, and cause the destruction of those legions, or at least the last component of those legions. So they can be used. They are being used on classical antiquity sites a lot today. And part of it's to find and guide archaeologists to deposits where they will gain the most information, not just to look for coins or stuff, but to actually find metal-bearing areas that will give us something about manufacturing or living areas or whatever. So lots of functions for that. Here's another example I did a few years ago, which is the Blackjack site in Kansas. This is where Henry Pate and John Brown met in the first pitched engagement of the pro-slavery, anti-slavery small war, if you will, the border wars in Kansas about the Free State versus Slave State stuff. This is on the Santa Fe Trail. That's the yellow area are the ruts of the Santa Fe Trail. And well, our job was to find the location of this little pitched engagement, which was located down in here. We know that Pate's wagons were parked up on this Santa Fe Trail area, and we used volunteer metal detectors and worked the area. While we did find evidence of the fighting represented by the bullets, and what's one interesting thing about this as an aside is that the Pate's Missourians were armed with the latest rifled muskets. This is 1856, issued probably from the state arsenals. So this may have had an overtone about who. These are all wagon parts on the left, and these would be from the Santa Fe Trail, and not necessarily from Henry Pate's staying there, but just wagon parts that were lost on this, and harness that was lost on the Santa Fe Trail. In addition, we found a large amount of metal material in a cluster, along with some ceramics that were laying on the surface or came out in the excavation holes when we dug up the metal targets. And that turned out to be the residual cache of materials that had been left behind by people on the Santa Fe Trail. This is not far from their starting point at Westport, Missouri, and as they moved across Kansas, and whether it's the Overland Trail in up north, or and the Mormon Trail and the Oregon-California Trail, or the Smoky Hill Trail, or the Southern Trail, it doesn't matter. People dropped things and discarded them and cached them, mainly perhaps for other people to use. The classic is get rid of that piano and we're not hauling that thing west. And those kind of things, we found these caches. So we actually had important trail debris, and we could see where camping sites were occurring. This was near water, surprise, surprise. But that information is out there. So these, not only do people lose things from their wagons and their harness, but they also either lost or disposed of things along the trail, and we can pick those things up. And metal detection is a very, very effective way to do that. Just with this John Brown site at Blackjack, we created view sheds using GIS based on the distribution of those combat-related items, the bullets, to see who had the best view sheds, and we can determine that. And so it's an application of what in military are called terrain analysis, or fields of fire. So weapons fan analysis is another term. So Henry Pate down here, this is what Brown could see as opposed to from different places within these environments. So he had a good field of fire, is what it turned out to be. So that's the kind of take it beyond the actual artifact and the distribution of artifacts and turn it into understanding of the actual combat functions there. Here's a case at Wilson's Creek Battlefield. Found an area there that by metal detecting that was obviously a large trash dump, this area here. We then just said, well, this is not what we want to do as professional archaeologists, get in that trash dump. We need to bring other geophysics in and see what we've got here. If the trash dump was there, we suspected it might be near a house, a cabin. It happened to have been occupied by General Price as his headquarters, but it was a homestead or a farmstead cabin of a guy named Edwards. And lo and behold, the geophysics did turn up a little bit of evidence of a structure of some sort in here, which has been later to be interpreted as the Edwards cabin location. And General Price's headquarters was important for Wilson Creek, but more importantly, we were able to find a farmstead home site based on the distribution of trash. By the way, there was nothing at all on the surface in that location other than this little rise. And I suspected that might mean something based on some little bit of experience in the world for a little time. This is another one, another site type. This is an Apache wiki-up in the Southwest. This is courtesy of Charlie Hacker. And we all know this must be protohistoric because there's nothing laying on the surface around here, maybe a few lithics. But when they metal detected this, lo and behold, it became 1850 or later. These are cartridge cases, cartridge and cartridge cases, tinklers, beads, bracelet, and bullets here, obviously projectile points, and a knife gun part here. So you don't always want to assume what you see on the surface that something isn't represented below it that might help date it diagnostically, because there was no metal at all on the surface of this site. Here's one in western Colorado. This is a wiki-up, a brush structure on the Uncompahgre Plateau. It was done by Curtis Martin of Dominguez Archeological Research Group here in Grand Junction, Colorado. And this is another one. There was no surface evidence of the dating of this site. Dendrochronology is being used to look at these trees, and they will give, without the bark on them and a number of missing rings, you just get a very variable date, the typical dendrochronology. So you don't have a solid date. And also the youth tended to pick up dead wood that had been around a long time. Pretty dry environment out here in the west. So that stuff lays around. And yet when they metal detected around them, lo and behold, they turned up tinklers and projectile points that would suggest mid to late 19th century. And in fact, Curtis has found stuff. We know the Utes were all driven out of this area in 1879, 80 after the Ute War, and placed on reservations in far southwest Colorado and in Utah, and they were never back again, except Curtis has found evidence of Native American Ute occupation and use of the landscape as late as 1914. So, and that's all based on the archaeological record of metal objects. So it's changing perspective. Another one that I got my nose stuck into, and of course I can't get away from George Custer, but we looked for, with Peter Bleed, the University of Nebraska, looked for the Hunt Camp of 1872. The guy there on the right is Grand Duke Alexei of Russia. He was on a worldwide, he's a sailor, he was on a worldwide diplomatic mission and also learning to be a competent naval officer in the Russian Imperial Navy. He was sailing around the world. He stopped in the United States, went to lots of different places, Niagara Falls, New York City, Washington, D.C., you name it, and Chicago and lots of other places, and ended up in the West, in Nebraska, doing a buffalo hunt with General Sheridan, George Custer, Buffalo Bill, and a few other dignitaries. They were showing him a good time. And they also brought in Spotted Tail, the Lakota leader, and about 600 of his folks. And we wondered, and we knew this environment was pretty pristine out there. We hoped it didn't have a center pivot on it, irrigation system, and it didn't. It's well preserved, and we were able to find cut nails and tent pegs, and here are the lead foil seals from the champagne and wine bottles that were. It was a big party. So the metal detecting found that. I talked to a couple of collectors who had been out there before us, and they had found nails and didn't think they were anything. It was obviously just a homestead thing. But we saw the nails that we were finding and realized, no, these are small framing nails and light construction. What we have, though, was photographs of the site as well. And the one on the lower left is the Grand Duke's tent. His accommodations has a stove in it, also a wooden floor. What were the nails used for? They were used to floor the dining tent seen in the center with Spotted Tail. They were used to floor the Grand Duke's tent and possibly General Sheridan's tent. And these things were all concentrated in one area. And when we overlaid the photographs, the landscape, they fall right into place the archaeology is. With this Grand Duke hunting camp, we were able to reconstruct it based on the archaeology and actually place the tents on the ground using Google Sketch, now Trimble SketchUp, as an example. So what we're doing is taking the physical evidence found by metal detectors and able to build these larger constructs with them. So it's not just about finding artifacts. The next case example I'd like to use is Pecos National Historic Park, where we work with Sue Einiger and Heather Young when they were both there. They're now moved on. Also Charlie Hacker, he's a guilty party in a lot of stuff I do. In metal detecting. Now, we did not detect around the Pueblo itself, and of course I would love to because A.V. Kidder's laboratory shack is there. But we did, through University of Nebraska with Peter Bleed, work that area. And our goal was to locate evidence of Spanish colonial and later trade with the Pueblo and with the Comanche and Apache who were coming in from the plains to trade with the Pueblos. And so we had a 500-year level, and we can see some of the students out. And we used fairly wide transects because we were looking to get a sample of just the area. Here's some of our sample plots, staying away from sacred areas and also from the Pueblo proper. But and these have been lined out based on possibilities where Apache or Comanche campsites and or other things might have been happening. This is the so-called trade fair area where supposedly trading activities occurred outside the Pueblo in this little flat area out here. We metal detected there for a little while, and we only turned up about 1,800 metal hits in 10-meter wide transects. We narrowed some of them up in some areas. The interesting thing about this is that this large block survey is really, really important for something that's not supposed to have much metal in it, because these are prehistoric Pueblos of great time depth. There's sure a lot of metal out there. Now, our sampling procedure is that we plotted in every hit, regardless of what it is, and then we only could excavate 20% of that sample. So we used a random number generator to decide what we're going to dig of any given transect, and then we were only allowed to collect 20% of that. So pretty judicious sampling, at least the collection process. Interesting thing about this, it shows you that there's been more of a modern, last 500-year imprint than probably anybody ever thought. And certainly a number of those big black clusters down in here are probably beer cans from the Pecos conferences and other activities from when it was a state park. And certainly most of the modern stuff. But we did find a few kind of interesting things. And I won't go to specifics of where, but we found some knife points and knives, and those are Spanish colonial knives. We found coscojos, dangles off of bridles. These two are very definitely early colonial Spanish. This one is much, much later based on XRF analysis, and it has a lot of late 19th, early 20th century alloy in it, so somebody had something out there pretty late. We've done XRF on almost all the metal out there that we collected. And we did find this, and several of these, which are carrot head horseshoe nails. They went out of style in about 1568 to 1570. Not that they couldn't have carried on a little bit longer, but the first contact with the Pueblos is 1540, 41 with Coronado. The next contact is 1598. This is probably solid evidence of Coronado at Pecos. Wouldn't have been found otherwise without a metal detector. Nothing, again, to speak of on the surface of this site indicating any metal laying around. So, and we actually have additional evidence of Santa Fe Trail out there, very strong evidence of that, as well as some campsites associated with the Apache and Comanche, and Glorieta Pass, the Battle of 1862, that helped decide the fate of the West as far as the Confederacy was concerned, keeping it in the Union. So there's a coalition of great time depth here that had to be sorted out from the metal typology as opposed to its stratification, which is not existent for all practical purposes. Almost all this stuff was found from less than 10 centimeters deep. Other metal detector applications in archaeology are using them in excavations. This has to be one from Little Bighorn again, but we use that as the metal detector. Once we start an excavation, make sure we weren't missing something of metallic importance. We were screening, of course, but things do get missed. Another application here, digging a military dump site. We were missing very, very small nails and things from saddles and other with a 1/4-inch screen, so we were running everything through over a metal detector. And notice we aren't swinging the metal detector; we're using it what's called a pinpoint mode, and having just dropping the earth on top of it won't hurt it, and able to get greater recovery of small objects that would tell us again what kind of activities have been occurring associated with that particular dump. Here's my other shot on underwater archaeology. You can use these machines depending on the model and type in water, and it's the coils and the antenna wire or the connecting wires are usually sealed systems. Not every, you have to check that out before you purchase one, but you can use them. Also notice how this coil box is being worn on the hip. It can be detached from the detector. Some you can, some you cannot, but you can work in water fairly easily with most detectors, but you always want to make sure that check the manufacturer specifications on that kind of stuff. Now, I'm going to move to a couple of forensic situations to show you how we've done some of these things and applying them in a number of different ways. This is a mass grave exhumation done for the International Committee for Missing Persons and Physicians for Human Rights in conjunction with the United Nations and the International War Crimes Tribunal in The Hague. This was done in the early 90s. Cal Calabrese and Ralph Hartley and I and Melissa Connor were kind of lead archaeologists on the thing, working with an international team of forensic anthropologists and a number of others from Belgium and a number of other places. But when we found the mass grave, we plotted all of the cartridge cases to determine whether or not there was a pattern there, because the eyewitnesses said it was an execution. The Serbians in this case said, no, that's something else entirely. We didn't shoot anybody. And yet there's all sorts of AK-47 rounds there. They're in a pattern based on the extraction patterns of that particular weapon that would indicate these people were lined up on the edge of the grave and shot, and then people went into the grave and actually administered coup de grace shots from 9mm weapons. So the data was there. It was used. We've used them actually in grave exhumations where we're checking to determine if there are bullets or jewelry or watches, credit cards, anything like that that might be affiliated with the body to help make a positive identification or presumptive identification that can later lead to a positive identification. This is, again, work in Croatia where you just literally use the detector in the grave and on the body. We did find, in fact, billfolds with wallets with credit cards and other identities underneath the bodies in some cases. Another one dealing with firearms. This is a murder investigation in Colorado that where somebody was shot, and the metal detecting along the side of that hog barn indicate what these white dots are. The shotgun pellet pattern, so you could reconstruct that the person was standing back here somewhere based on the patterning of the shot pellet distribution. This would not have been good for magnetics, obviously, because you're right up against a metal building. You got the metal feed bunk back here, and so this would be a case where metal detectors, which can work within very, very close to other metal objects, within a meter or less, is a good example of what you can do with this thing. And we've used this on battlefields as well, with looking at distributions of canister, shotgun pellets from shotguns or buck and ball loads and things like that. Now, I'm going to conclude up with a couple of statements, and again, I'll be happy to take questions. Metal detectors are pretty darn useful tools. I think as archaeologists, there's still some resentment and residual feeling that maybe they shouldn't be used, but I find them on historic sites to be absolutely the most effective tool for determining boundaries. I can do it quickly. I can do it easily. I can teach others to do it pretty easily. You can define site boundaries based on the distribution of metals. You don't even have to dig the stuff up. Like at Pecos, we were able to see large masses of stuff and sort of using random number table generators sample it and determine how much of it was modern and how much it was older. The density of metals allows for more efficient excavation or other sampling planning, and it's tremendously more useful than shovel testing on metal-bearing sites. And now I'd like to point out, if I'd had to do shovel testing at the Little Bighorn at a 5-meter spacing over the area that we did in all those years of working out there, we'd have dug 45,000 shovel tests. I'd still be there. And we would have found, according to when I laid the array out over the actual artifact pattern that we had, we would have found less than 50 artifacts on that particular site by using conventional shovel testing techniques. So the metal, on historic sites, metal detectors are a far better tool than shovel testing. It doesn't rule out any other traditional archaeological method, but it is an enhancement that allows you to be better able to place things. Now, the important thing to know is that metal detectors only can be used on sites containing metals. This is sort of a duh, but it's obvious. They are only relatively shallow depth penetration. Now, as I mentioned, some of the new Pulse Induction machines can go as deep as 3 feet and find really, really small objects. So that's a different story, but you have a very significant investment in cost. The coil size is partially dependent on depth. 8 to 11 inch coil will get you the 30 centimeters or a little bit more. On a consistent basis, smaller coils will go somewhat smaller and deeper. Larger coils will go deeper. Like any other tool, electronic tool, the larger your size of coil, the less resolution you get going deep, unless it's a pulse induction machine. So those are important kind of points to remember. And that's pretty much the end of things as far as what I wanted to say. A couple of just addendums, if I will, or can. One thing I have been surprised at is the lack, or what I believe to be and perceive to be the lack of interest in archaeologists in applying these on sites in the potential copper-bearing sites up in the Great Lakes area. Looters are doing it, and they're finding the copper-producing sites and also manufacturing areas. And I don't understand why archaeologists haven't said this is a tool to find some of these things and understand how this stuff was being produced and then moves into the mound sites and villages and so forth. On the other hand, I do understand the reluctance of some people based on things happening in the east and the dyed-in-the-wool looters out there, particularly on Civil War sites. I'm a big believer in using volunteers, but I've only had one really bad experience in over 30 years of doing this, and that was dealt with fairly easily. But I do get it that other places don't have nicer people that I get to work with. So there's a lot going on. There's a lot of ways to do this. If you're interested in metal detectors and purchasing one, or you can lease them, I really suggest that you get in touch with a local metal detector dealer. They will know the soil types in the area. They will know what machines work the best for your environment. There are machines that work across the U.S., across the world, and if you have questions about that, I've had enough experience with that. I'd be happy to advise you, and you can drop me an email or something. I'll be happy to help you. And I don't. There's certain brands that I work better in some places than others, but there we go. So I'm gonna shut up and let you guys ask questions or escape, whichever you'd like to do.
Thanks very much, Doug. Do we have any questions? Well, I have a question. Doug, you had talked earlier about the difficulties or the sort of the fine line that you have to walk between using volunteers and the messages that can be sent, or the way that the public is perceiving archaeologists who use metal detectors. Do you have any advice for us and how to negotiate and navigate that?
Well, I can give you my own personal experience, which is we very carefully vet anybody who comes on. We don't just say, "Yeah, come on out with us." We'll ask them to actually apply and give us a little bit of background. And you can usually tell in a conversation with an individual whether or not they're trying to milk you for information or use you to figure out how to sneak into that site. There's just body language and the way they say things that you know that they're not going to be a person you want around. That's learning how to deal with people, of course. But I've found many people who are very, very trustworthy, and I personally have a group of volunteers that I like to call on to be kind of a core group. They've worked with me many times, and they will then work with the newer volunteers that come in from a local area. And those individuals very often do not detect unless they are on a site with a professional archaeologist. The ones that I have as my core group, that they're not out hobbyists. They want to do this because they really want to contribute to the archaeological world. I've built that cadre up over time, and those folks acting as a core will also help me monitor the others out there. First of all, I trust that core group. And that they have spotted people that not stealing anything like that, but maybe you question whether or not that the ethics are really there, or if they don't want to follow directions or something, so you can learn how to work with them a little better. Again, I've used volunteers on digs before, and not just not metal detecting. So, I'm a big believer in that because it gives the public people can say, I was on this project. And in a lot of cases with metal detecting, I think when these metal detectors realize professional archaeologists respect their capabilities, not necessarily whether or not they collect, that's another issue, but they respect their capabilities using that, they're going to get to work in places they never would be allowed in otherwise, with good reason, and then they can say they helped discover and preserve the past. That sends a message out to the other hobbyists as well. We're not going to convert everybody. I know that, but if we can convert a few, that's a big step in the right direction. So I don't think we should ignore them. There are places and times you don't want to use them. I agree with that. Absolutely. Other times I think it's a great PR tool.
Well, what is the allure for metal detector users, the volunteers, if they can't keep the things that they're finding?
Just a personal viewpoint is that I bet 80% of those people don't really care whether they keep something or not. It's the thrill of being out there and doing something outside and altruistically. Some of them really want to help archaeology and understand the past. Others, it's just great fun to be out there. And if they find something and can see it, take a picture of it, that's cool. They're happy with that. And I bet that's probably 80%. There are the dyed-in-the-wool people that want stuff. Those are the people I don't want around.
Well, thanks very much for being so candid about that.
Well,
it's always been a tricky issue for me to understand.
I think it is a tricky issue, and it depends on where you are. The folks I've talked about, southeast, with Jan Corneliuson and many others with issues down there on those battlefields and those historic sites where people are looting left and right is a different story, and I think it has to be treated, differently. I wouldn't want to go down there and hire or get a bunch of volunteers in without having somebody else that knew those people well.
Do we have any other questions? People who would like to make comments?
Yes, this is Michael Peterson, archaeologist, Redwood National Park. Hi, Doug.
Hi, Michael.
Been a long time since I've visited with you.
Yeah.
See, I had a question. It's kind of complex, I suppose, maybe, but briefly, could you address, one of the things that I would consider when you would be extracting, say if you find a piece of metal or something with your metal detector, and taking care of pulling it out of the ground, depending on if you're in a plow zone or in a virgin sod, what type of considerations do you do, and what's some of your methodology?
Well, I think you just said it. It's the context that we're digging in. And whereas, say, a hobbyist isn't going to understand that at all, or largely won't, we as professional archaeologists do. And so once something that's in a plow zone is a little less, it's been disturbed probably. And so it's taking it out. Most everything I do has been GPSed in. But actually digging it up, a lot of times you got a target, you go in and you find it and you recover it. With the smallest footprint of disturbance possible. We've gotten a couple of cases where we get down on something and realize, whoa, this is something else, this is bigger, this has more context, there's other things around it. So we'll halt that metal detecting part of it as far as the recovery concern, a small hole, and go to a formal excavation unit or test unit or something like that. It's all about context. And knowing, what you're likely to be recovering. We worked in a big hole, Montana, in the native village there that was attacked by Colonel Gibbon in 1877. We dealt with specifically what we thought were teepee sites. We were looking for some patterns of stuff. One of them we got into beads associated with metal objects, stopped, and opened up a test unit in there to determine if we really had or what we had. And that worked out real well. So context.
Thank you.
we have any more questions or comments?